Hi everyone. Welcome to the Marine Search and Recovery webinar. My name is Brittany Hines, Marketing Specialist here at HYPACK, and I will be your host for today's presentation. So, for today's webinar, we are going to show you how HYPACK Marine Search and Sidescan software works and can make a difference in police and fire agencies to better their search and recovery operations. I would now like to introduce to you our HYPACK Customer Support Manager, Mr. Jerry Knisley. Jerry joined HYPACK in 1997 as a support technician and served in this role for 16 years. In 2013, he was promoted to Technical Support Manager. Previous to HYPACK, he served 9 years in the U.S. Navy as a submarine serviceman. During his 20 years at HYPACK, he has provided technical assistance for customers in 6 different continents and over 20 countries. Jerry has vast knowledge and experience in all aspects of hydrographic surveying, utilizing both HYPACK software and the extensive catalog of sensors that HYPACK supports. He brings extraordinary experience and expertise to our company, and we are so happy to have him here today with us to talk more about our marine search and recovery software. So now I'm going to turn over the presentation to Mr. Jerry Knisley.
Thank you, Brittany. I'm excited today to share the marine search software and what we can do to assist people in their search requirements. One of the things we're going to talk about is a real-time mosaicing feature that ensures the area searched is cleared and there's nothing left to chance that we may not have found the target we're looking for. Then we're going to talk a little bit about real-time target investigation and location to reduce the time to dive on an incident so that the divers are more prepared when they enter the water. And utilizing this information, we can better prepare our divers to be safe once they do enter the water. At the end, we're going to discuss some examples of what we've done with the New Haven Fire Department to increase their search abilities and with the tools they've already got. First, let's talk about HYPACK a little bit. I started 20 years ago with HYPACK. It was founded in 1984, and it's primarily a hydrographic survey software. That's what the software was intended for when it was first written. We've included judging and high-speed products, but we've also added the Sidescan to the software that we provide. Using the side scans that we do for surveying, we can now provide those to a search environment and better utilize the tools for the focus of marine search. One of the reasons marine search came about was because of the number of incidents where people are lost in the water or accidents occur, and we needed to provide a software for our customers to be able to go out and search in these environments or during one of these incidents. The slide we're looking at here discusses the number of incidents over the last 20 years. You can see according to the last 20 years, the number of incidents have declined. However, they still number in the thousands. This only covers the United States, and outside of the United States and the world, this is also a problem. The source of this slide was from the U.S. Coast Guard. So one of the things we need to talk about when we talk about marine search are the tools that are required when we do one of these searches. The first thing we're going to discuss is a GPS. Now, most people are familiar with the GPS process and how we would use a GPS. You have a cell phone with a GPS in it for navigation. A lot of people have a GPS in their car. So when you're out surveying, we need a little bit better GPS than that. The GPS in your cell phone is accurate to about 24 feet. It seems to be a little bit more accurate than that. However, they can't guarantee it. What we need is a guarantee that we're close nearby the target that we think we are, because in a lot of cases we're searching for someone's loved one. So we want to make sure that we identify where the target is, where the object is that we want to dive on as accurately as possible, reducing the diver's time in the water, reducing their exposure to the hazards of being in the water, and also recovering whatever it is that we found during our search as quickly as possible. The way this works is our GPS, which again you have one in your cell phone, but the GPS we use in a search uses a reference station. That reference station is located somewhere nearby on land, could be, up to 50 to 100 miles away actually, and it knows where it's located. It receives the same GPS signals that our GPS on our boat is going to receive, and it computes a position. However, it knew where it was, and it knows where it thinks it is, and it computes the difference between these two positions. That difference is the error corrections. These error corrections are transmitted over the radio waves, and our GPS picks those up and corrects the position that we thought we were here. However, with the corrections, we know exactly where we are within about 3 feet. That is very important for the diver, because if we can put a diver very near the target that we want him to dive, if it's a bad visibility, if it's cold water, if it's a rough situation, we are going to limit the amount of exposure to danger that the diver has by limiting his time in the water. The second tool that we're going to talk about is we're going to discuss Geodesy. The second part to this is we have to be able to put this on a map. By putting it on a map, we have the ability to share this information with other people, with our divers, with post-search analysis. So what we need to know is we need to know where we are on the Earth, but we also need to project this on a map, and Geodesy does that for us. It takes our position in latitude and longitudes, and it allows us to project this on a 2D plane, which would be your map. So the other sensor that we're going to use in the field is a Sidescan sonar. The Sidescan sonar allows us to see what's in the water on the bottom and project that as an image. So we see on the left, we see the Sidescan view image, and there's a car upside down on the bottom projecting a shadow. The shadow is the dark area to the left, and the car is what you can see is the bright spot. This one's very clear and easy to understand. To the right of that is the water column. The water column is directly below the sonar and is the area that there is no actual returns. So we're actually getting the image of what's directly below us in that area. When we make this on a map, we're going to eliminate the water column area. The image to the right, where there's a big X, that would be the sonar. And below that, you can see the blank area where there's no information. The sound waves are emanating out from the sonar, and you can see the boat on the bottom in red, where that would be the target that we're trying to find. And to the left of that is a little gray area that's a triangle. That would be your shadow. The shadow is going to be very important to us. The importance of the shadow, as you can see here, is it gives us amplifying information and tells us what we're actually looking at. The top image is a Sidescan sonar traveling through the water, and you can see there's a little can to the left of the Sidescan sonar in the image, projecting a shadow on the bottom. It's very much like taking a flashlight and shining it on something. The Sidescan travels through the water, it emanates the radio or the sound waves out that we get the returns much like a bat when it would fly through the woods so that it would avoid a tree. The second image on the bottom left shows a bright spot in the middle of the image, and we've removed the shadow from this image. Without the shadow, I don't know what that image is. It's actually just a target that I would mark, but if you look at the image to the right, you can see with the shadow, it tells me that it's a bicycle. Now this is very clearly a bicycle, but without the shadow, I wouldn't know that information. So the benefits of marine search software. Well, because HYPACK is integrated to a lot of different softwares around the world, and or different sonars and different geodesies that we can work with, we've also integrated to a lot of Sidescan systems. We've brought those Sidescan systems over into the marine search environment so that you can use whatever equipment you have already purchased or buy one of the sonars that you need to go out and do your searches. The second benefit is a quick setup to survey time frame. The quick setup to survey time frame allows us to get on the water and search as quickly as possible. The way the software is designed, everything's done within a project folder, and all of your information from the search would be contained within that folder. By using an individualized project folder for every incident that you have, you can contain all of your search information and all targeting information for project writing and reports at the end. The third thing that we do is we're able to output to a TIFF import, or output to a TIFF image. The TIFF image allows us to display where we were. You can bring it up in Microsoft Office, you can bring it up in a lot of different of the CAD packages and see relational data between two targets. Now, the last thing we're going to talk about is real-time sonar mapping. This allows you to ensure that you've covered all of the bottom and haven't left any gaps or any areas unturned. Remember, if we're looking for someone's loved one, we don't want to leave an area that could possibly have been the person or the object of interest when we finish the survey and have that doubt if we have not recovered what we were looking for. We're going to discuss the initial configuration of the software. We've tried to simplify this so that it's only done one time so that it carries through all of your incidents. Most search teams are going to have one set of equipment installed on one boat, and that system is going to be used over and over. By doing this configuration one time, we're going to be able to configure what hardware we're using, which geodesy we're in, and reuse that over and over. At the top here, we see the geodesy on the left. We've discussed geodesy already, and if you're working in the United States, the state plane is all you have to choose. You choose the state plane in the 83 option, and then under the zone, you would choose the state and the zone you're in. In Connecticut, we have one zone. Below the geodesy, you see the GPS Connect option. Most GPSs are going to connect either serially or over a network device. That allows us to talk to the GPS and receive the coordinate information that we need to better plot where we are. On the right-hand side, you see the Sidescan sonar and the Sidescan Connect options. All of the right-hand portion is to connecting to your Sidescan system. The drop-down box at the top allows us to choose the model and manufacturer of the sonar we have, and a setup button if there's any setup to this system. Below that, you'll see the Sidescan Connect. The Sidescan Connect has a connection test and allows us to type in the information that we need, again, serially or network, to talk to the Sidescan that we're working with. On the bottom right is a waterfall test button. Before we deploy a sonar in the water, we want to make sure that the sonar is working. By using the waterfall test button, we'll see the data streaming from the sonar and allow us to do the rub test that is usually performed before the sonar is dropped into the water. Here's a list of sonars we currently support. A lot of these sonars are used for archaeological and other surveying purposes. We can, in fact, use all of these for the marine search environment. So if you have a valuable one of these sensors, you can use it within the marine search software. Typically, a lot of people will have one of the sensors for a searching or a surveying environment can be also deployed for this case. The New Haven Fire Department told me they had a Hummingbird Sidescan mounted on the boat, and when I went down there to give them training, they also had a Klein 3500 Hydroscan that they didn't know that they could use for the same purposes. So once we've configured our Geodesy and set up our incident report, we want to go out and conduct the search. I recommend before you go to conduct a search in a high-stress environment during an incident, you take the information, you go out and you survey with it just a couple times in areas that you don't know so that you become more familiar with how the equipment works. So now we're going to discuss conducting the search. We're going to create the incident by creating a project name. HYPACK works with projects. In each one of these I've described before is a folder that we use to contain all of your information. By creating the project name, in this case, I've made this one up for the New Haven Fire Department. You can call it whatever your incident report is. It will contain all of your information. Now, we're going to go out and run the search. We've gone in, we've set up our Geodesy, we've created an incident report. We can bring in any background charts or maps that we need to use, and then we run the survey. Once we run the survey, you're going to get two windows that are going to assist you during the survey. On the left, you'll see the survey window. In that survey window is an ecdist marker that shows the position and direction the boat is traveling. On the right-hand side of the ecdist marker, you see some caissons that are on the bottom. On the left-hand side of it, as it's traveling down the screen, you can see the sand waves. The image to the right shows the Sidescan survey window, which is the waterfall that we discussed earlier during the rub test. In that window, you'll see the information coming directly from the sonar as we travel through the water. You can also see, in this case, the water column data has not been removed, and you can see any information that's in the water column. Later on, this will become important. What you can notice in this window is that the Sidescan data is being portrayed just image after image stacked on top of each other. The image on the left is actually georeferenced mapped information that we can go back to if we needed to. The Sidescan window. It's important to understand what the Sidescan window provides us. If we are driving the boat, the person that's running the sonar can watch this screen to see any targets or any information that appear. This image is from a bunch of caissons that were surveyed off the beaches of Normandy, and you can see that as we got close to one of the caissons, we could tell the operator you need to turn left or you need to turn right to avoid an object in the waterfall display. You can see that the water column data has not been removed. We do not recommend as you survey that you remove the water column data until you've post-processed the data. Along the top, there are two green and two red buttons. The two red buttons indicate that there was a problem with those sensors, and the two green indicate that those sensors are working properly. So here we're going to discuss safety of ship. It's always important when you're on the water to maintain safety of ship in an environment where we want to make sure that as we search, we can do it as quickly as we can, but we're also safe about our jobs. The altitude window shows us that the depth below the sonar is only 1.6 feet. That's also indicated at the top right in the red box. It says altitude 1.5 feet. You'll see the three green bars, the nav, Sidescan, and devices are all green. This indicates to the operator that all the sensors are coming in properly, and although we are in a very shallow environment and risk damaging our sonar, we are collecting good data. So, real-time mosaicing. Real-time mosaicing allows the boat operator, as you're driving the boat, to maintain 100% coverage of the area to be searched. You'll see that below the ecdist marker you can see a little bit of a white area that's a gap in data. Gaps in data leave doubt. Remember, we're looking for someone's loved one in a lot of cases. We're looking for something of importance to us that we need to find as quickly as we can. And if we leave these gaps, we're not sure that we've covered the area. We do not want to leave gaps. At the end of the day, you in a survey environment would have to redeploy your boat. In a search environment, you've left doubt that you may not have found the person or the object that you're looking for. The second thing that we want to do is if we've left a gap like this, because it's invariable that it's going to happen on the water, you're able to go back and cover that area before you pull the boat out of the water for the end of the day. So the next slide we're going to look at here is adequate coverage. Adequate coverage, this is a survey from Hartford, Connecticut that I did using the Marine Search software, but I was not using the RealTime Mosaic at the time I did the survey. We were out testing the area to determine what the bottom looked like in one of those pre-survey tests that I was discussing that I recommend everyone does. There's a large gap in the middle of the river that I wasn't able to connect the data there. You'll see on the left-hand side there are several black circles. Those black circles are cars that we found on the bottom. There were 5 of them that we identified using the Marine Search, and we knew that they were there. Once we did the survey, we were able to turn that information over to the Hartford Police Department. You'll also notice that the large gap in the middle is very long. If we had been looking for someone's loved one, this would be unacceptable. We would have had to go back to collect that data in the middle. So now we're going to look at it. When I say control the search area, this is something that you need to do. One of the things we're looking in a case where we're looking for someone's loved one or looking for something time sensitive, everyone wants to be on the water and you have a lot of volunteers and you have a lot of departments trying to search in the same area. This is a survey that was done just as a survey and not a search, but I use it as a slide because you can see all of the boat wake. All of the white transects that you see through the survey data are actually wakes from other boats that were traveling in the area while we were trying to survey a shipwreck. If you were out looking for a person or someone's loved one in this case, all of those wakes would obscure the bottom and you would not be able to find the person. If you see this in your survey data, you need to go back and recollect data in that area because there's nothing that can be done to fix this. If you control the search area and control the environment as you're doing the search, you're better able to eliminate the effect of boat wake on your search. One of the things that we recommend is while you're searching, you continue the search. If you find a target of interest, you find something you want to put a diver on, mark the target, pass the coordinates to a dive team and continue to search because there's going to be many things on the bottom that look like what the target is you're looking for but may not be the target. So we're going to discuss real-time target investigation, which we want to continue the search like I just said. So we want to mark a target, we want to know what it is, we want to investigate it and either determine it's not something of interest or it is the target we want to put a diver on. Here we have, again, the survey screen and the waterfall screen to the right. In the left screen, you'll see the Ectis marker going up the screen, and to the right of it, there's a target that I marked in the waterfall. In the waterfall to the right, you'll see a red bullseye where I double-clicked on a target that I wanted to mark and investigate. As I mark that target, the target window that you see in the middle of the screen pops up on the screen and allows me to do length measurements, width measurements, height measurements. I can type notes, I can rename the target, or I can determine that this is not a target of interest and I can delete it. If I close the window without deleting the target, it gets stored in an SQL database. So target determination on the fly. These slides show us a target of there's a diver on the bottom in the target window on the top right. There was a search and I was involved within one of the fire departments locally. We thought we had found the target of interest. We marked the target. We continued our survey. We determined that this was something of interest we wanted to put a diver on. So we marked the target and put the diver on it. We were able to position the diver by using the target on the screen. The diver radioed up to the water, to the surface, that we were not on the target. It wasn't what we thought we were looking for. We were convinced that we were, so we asked the diver to lay on the bottom, and in the survey map window on the bottom left, you can see at a safe distance we drove past the diver with the sonar deployed so that we could see his relation to the target of interest. In the bottom right screen, you'll see I double-clicked on the diver again, marked his target, and on the map window to the left, both targets overlaid each other, so I was confident that the diver was on the target that I was looking for. This was a way we were able to minimize his time on the bottom to verify that the target we were searching for was the one that he had identified on the bottom for us. So here we have another example of a target. In this case, it's a car in Hartford, Connecticut. And in the map window to the left, you can see the real-time mosaic with the car and the shadow. In the waterfall to the right, circled in red, I've double-clicked and marked my target on the car, brought the window up, and identified the car. The window and the target I can measure, like I said before, put notes on this target, and better utilize my tools to store this is what a car looked like on the bottom. If you do the training like I'm discussing and go out and search the areas that you're going to need when it's a low-stress environment, you can identify targets like this on the bottom so that in the future, when you are looking for something of interest, you do not have to identify that target twice. Here we have an image of a car. What can we provide the diver? In this particular image, you can see that the car is upside down, there's a shadow on the bottom, and the gray box is the actual car. And the red box is the shadow of the car. By knowing this before the diver enters the water, the diver can verify what he's going in the water to see. He can enter the water safely and find the object on the bottom more easily, especially in a low visibility environment. In this particular image, there's not a lot of debris around the car. The diver can get into the water. We know where the car is, and it's going to be a safe, fast dive for the diver. So I talked about everything being a target, and I call them targets all the time because until you pull it out of the water and put your hands on it, you don't know what it is. In this particular image, you see the shadow, you see the car. It looks like all the cars I've ever seen. It's upside down. A lot of time, cars, when they go in the water, they'll turn upside down. The engine will be heavy. Air will accumulate in the back and the car will roll over. You see the car on the right, that's the same car that you see in the side scan image. By knowing this information, the diver was able to walk in and dive right to the car. So targets are hard to identify. Up to this point, we've used an example of a bicycle and some cars. What you're looking at is the side scan image of an F-16 that hit the water over 200 miles an hour. The pilot ejected. In this particular image, by going out and knowing the area, this doesn't look like an airplane, but we were able to determine, the person that was surveying, that it actually was something different than the surrounding area, and they were able to verify that is an F-16 on the bottom at 200 miles an hour. It's very important to note that everything around it looks different, and that's how you're going to identify when you have a target, if you know what the bottom looks like and something doesn't look similar to what you've seen before. So I keep referring to putting divers in the water. A lot of departments use police divers or fire department divers and police or fire department search, and you're going to work within the confines of your area of who's going to be in the water. It's important to verify what's on the bottom and to help the divers better prepare themselves. Diver safety is very paramount. You want to make sure that by investigating an incident, we don't create another. In the image below, you can see the sailboat. The sailboat on the bottom is in New Haven. We're able to image it using the Klein 3500, but forward of the sailboat is another secondary debris field. If we had this image and we were showing it to a diver, he would know that if he entered the water from the sailboat, if he left the bow of the sailboat and swam directly out in front of the boat, he would find the secondary debris field. If you're working in dark water or low visibility environment, or you're working in a cold environment, this can be very useful to assist limiting the amount of time the diver spends on the bottom. By limiting this, he knows what's there, he knows what to expect, and it's better able to perform his duties underwater. Here's another image for diver safety, and I like this image for a couple reasons. The one on the left is near an outfall in Hartford, Connecticut that we surveyed during the marine search testing I was talking about. That image on the left, if we were there to retrieve a personal effect or in a lot of cases a loved one, we need to go into the water in a safe environment. And if knowing that a lot of the Hartford, Connecticut River area is sandy bottom, but this area particularly is not, and if we found a target in this area, it'd be good for the diver to know what to expect when he got to the bottom, limiting his danger and time on the bottom. The image to the right shows in that water column area debris near the bridge pilings. The debris near the bridge pilings doesn't show up in any of the side scan data except for the water column data. By showing up in the water column, you can actually limit the danger to the diver if he was going to work near these bridge pilings. Entering the water near bridge pilings is already a dangerous environment, but by knowing that there was a tree near those that showed up in our water column as we drove directly over top of it, the diver is better prepared and again, safe to enter the water. Sharing your survey data. Up to this point, everything that we've discussed has been about entering divers into the water and recovering things. A lot of the tools in marine search is so that you can write reports at the end of it and know what you did, the lessons learned to get better, and to share your data with other customers or other environment. What we're doing here is we have the side scan data as a mosaic, and then we've exported it to Google Earth. The TIFF image can be viewed in Microsoft Office for report writing. It can be used in any of the paint programs, a lot of the CAD programs, but one of the nice features is that we can export directly to Google Earth. You can format this data and send it to a customer that has no idea what the marine search software looks like. They can bring it up in Google Earth, and then using the maps and the images that you see on the screen, you can determine relational data to other objects on the ground and maybe plan for a better dive in the future. Post-search target investigation. So we have those targets that we've been marking, and it goes into an SQL database. The nice feature of the SQL database is it builds up over time within that incident, and you can see the time, the date, the position, which program created the target, and also any notes or links with measurements that you've taken of the target so you can investigate later on and go back to the targets of interest. During a search, you may have found other targets that you want to investigate that weren't the primary target but need to be investigated afterwards. The image to the bottom right is the target editor. In the target editor, you have the name, all the same information, but you also get the image of the target as it was collected in the software. So in this case, we marked a car. You can see the car in that image, and you can go back and write more notes and more detailed report after the fact. Here we have the New Haven Fire Department Marine One boat. We've been working with New Haven for several months so that we can increase their search abilities and provide them the tools that they need. New Haven has a couple of Sidescan sonars, and they've had 5 incidents over the last year where they've had to enter the water and go out in a search environment. A lot of the times you want to deploy yourself as quickly as possible. One of the things that New Haven's determined that they wanted to do was to create a search grid so that they have a better service and ability to work in that area. They've focused on the U.S. National Grid. With the U.S. National Grid, New Haven's able to plot that information within the HYPACK Marine Search software, which is a scalable ability for them to work within other districts and other surrounding communities and provide coordinates that would be able to be used by any of the other environment or police, fire department units in the surrounding area. The U.S. National Grid is also a focus of FEMA for incidents or natural disasters. By utilizing this in the Marine Search software, the City of New Haven Marine Search, they have the ability to go out, if they're looking for someone's loved one, very quickly deploy their vessel and find the search area and verify that they've cleared the group zone or place a mark for a diver to go into the water.
Thank you, Jerry. That was a great presentation, and we are so excited about this new and simple software solution, and hope this gave everyone a better understanding on how the HYPACK Marine Search software works and can better police and fire agencies' operations. So now there were a lot of questions that came in, so let's go ahead and start the Q&A section of the webinar.
Okay, the first question that I have is, how long should it take to learn the software? One of the things about the software is that once you've gone out on the water and you've learned how to use it, you can repeat this and get a better familiarity with the software. It takes about a week. That's usually what it takes us when we train somebody to get out on the water and get comfortable using the program to find the information that you need and to get used to surveying with the software. After that, it takes a little bit of time to repeat yourself and survey more just to become, it's not something that fire departments and police departments are going to use very often unless they do it in training. So after about a week, you'd be comfortable with the software. My second question, is there any support offered when we buy it? Yes. HYPACK offers technical support to people that purchase our software. The technical support is 9 to 5, Monday to Friday. However, we do offer after-hours support for an on-call technician. The on-call technician can help you if you're out surveying or if you're actually during an incident and have trouble with the software. We can go out there and help you over the phone or over the internet, fix the software or understand what you're looking at. Okay, our third question. After a target is located, how do we go back and investigate it? Those targets that we marked, they show up in your map window. So even before you leave the water, if the sonar is deployed or if it was pulled out of the water, you can use those targets to drive your boat directly on the map right back to that target. Driving back to that target, you can put a diver in the water. You can run the sonar past that target at different angles to get better images or different images. That will allow you to better use the targets that you've marked and verify whether it's the target of interest. So one of our questions, is this feature in HYPACK 2014? The Marine Search software is a separate standalone package that's not part of HYPACK. The Sidescan survey and mosaicing software is a part of HYPACK 2014. Another question we have is the GPSs, and what type of GPSs do we recommend? A lot of times customers that survey have a Trimble GPS or a Hemisphere GPS. Those are the two most popular ones. Higher end navigation, MRU, IMU type information can be used, but it's not something that's required. There are several commercial GPSs, and Hemisphere is probably the one we see the most with the marine search environment. This is another question someone asked, what can we do with the target database? By being an SQL database, you can search the target database based on coordinates or notes to find a target and identify in multiple searches. Let's say we went out with the boat and we were going to survey an area. We could go out and determine which targets were there, and then during a search, if we wanted to, and we marked a bunch of targets, we could go back and search the database to see how close other targets were to that target, and if it's something we've identified in the past.
Okay, everyone, we are unfortunately out of time, so we're going to wrap this up. We want to thank you all for your participation, and we hope you enjoyed the webinar today. Everyone will get a copy of this presentation, and we will get in touch with anyone who had unanswered questions over the next week or so. Also, please don't hesitate to contact us. We want to hear from you. We can be reached at sales@hypack.com, and don't forget to check us out on Facebook, Twitter, and LinkedIn for upcoming news and updates. We hope to talk to you soon and have a great rest of the day.